Imagine the vast canvas of our universe unfolding before your eyes, a symphony of cosmic forces that could reshape our understanding of the world around us. As we stand here on August 24th, 2025, gazing up at the skies, something extraordinary is brewing on the sun, a massive plasma filament eruption that erupted just days ago on August 19th to 20th, captured in stunning detail by NASA's Solar Dynamics Observatory. This isn't just a fleeting solar tantrum, it's a colossal event in solar cycle 25, one of the most spectacular we've witnessed so far. Picture this: a twisting rope of superheated plasma, tens of thousands of kilometers long, suddenly snapping free from the sun's surface and hurtling into space. Over the next 7 days, this eruption's effects will rotate directly toward Earth, potentially bathing our planet in charged particles that could spark dazzling auroras, disrupt satellite communications, and even influence our weather patterns in subtle ways. But hold on. This is only the beginning of a cascade of celestial dramas that are intensifying right now, growing in power, size, and strength, as if the cosmos itself is awakening. Stick with me through this journey, because by the end, you'll see how these events interconnect in ways that might just blow your mind, urging you to keep watching the skies and pondering what it all means for us here on Earth. Let's dive deeper into this solar spectacle. Solar filaments are dark, serpentine structures suspended in the sun's corona by magnetic fields, often appearing as prominences when viewed against the solar limb. When these fields become unstable, the filament can erupt, launching a coronal mass ejection, CME, a billion-ton cloud of plasma and magnetic fields racing outward at speeds up to 2,000 kilometers per second. The recent eruption on August 19th to 20th was no exception. It was heralded by an unexpected M-class flare, signaling the sun's restless mood. According to data from the Space Weather Prediction Center, solar cycle 25 is nearing its peak, with sunspot numbers hovering around 87 as of August 23. These sunspots, dark blemishes on the sun's photosphere caused by intense magnetic activity, are the breeding grounds for such outbursts. Interestingly, helioseismic maps reveal 2 active sunspot groups on the sun's far side, which have already flung CMEs into space on August 21st. As the sun rotates every 27 days at its equator, these regions will soon face Earth, potentially escalating the drama. Why does this matter? When a CME collides with Earth's magnetosphere, it can compress it, injecting energy that manifests as geomagnetic storms. We've seen KP indices at quiet levels of 2.00 recently, but forecasts predict a 35% chance of M-class flares, an incoming solar wind from a coronal hole arriving August 25th to 26th, which could ramp up to minor storm levels. This high-speed stream, flowing at over 400 kilometers per second, originates from coronal holes, regions where the sun's magnetic field opens up, allowing plasma to escape freely. Historically, such events have coincided with increased auroral activity, like the stunning displays during the May 2024 solar storms that lit up skies worldwide. As this filament's influence rotates toward us, expect possible radio blackouts, GPS glitches, and even power grid fluctuations, reminders of how intimately connected we are to our star. But don't stop here. This solar surge is just one thread in a larger tapestry of escalating natural phenomena that seem to be syncing up in intriguing ways. Shifting our gaze earthward, the oceans are churning with their own monsters, mirroring the sun's fury. Take Hurricane Erin, which recently roiled the Atlantic before transitioning to a post-tropical system on August 23rd. This beast started as a tropical depression, but rapidly intensified into a major hurricane, peaking as a Category 3 with sustained winds over 115 miles per hour. Imagery from NOAA's GOES-19 satellite, the latest in the Geostationary Operational Environmental Satellite series, shows its sprawling structure off the eastern seaboard of the United States. The long-wave band, 13 infrared views, reveal a massive swirl of clouds, while geocolor composites highlight the eye's symmetry and the surrounding thunderstorms. Aaron underwent rapid intensification, jumping from tropical storm to hurricane status in under 24 hours, fueled by warm sea surface temperatures exceeding 28 degrees Celsius and low wind shear. Although it steered clear of direct landfall, it delivered storm surges up to 4 feet along coastal areas from North Carolina to New England, along with heavy rainfall exceeding 6 inches in some spots, causing localized flooding. Now, as Aaron dissipates, attention turns to tropical storm Fernand, the sixth named storm of the 2025 Atlantic hurricane season, currently at 28.8 degrees north, 61.2 degrees west with 40 miles per hour winds, moving north-northeast at 16 miles per hour. Forecasts from the National Hurricane Center indicate it could strengthen slightly, but remains a threat for rough seas and rip currents along Bermuda and the U.S. East Coast. What's fascinating is how these cyclones echo larger cosmic patterns, their spiral arms resembling the arms of our Milky Way galaxy, a visual metaphor for the interconnectedness of scales in the universe. NOAA's prediction for an above-normal season, with 13 to 19 named storms and 6 to 10 hurricanes, is playing out, driven by La Niña conditions and record-warm Atlantic waters. These storms aren't just weather events. They redistribute heat and moisture globally, influencing everything from agriculture to ecosystems. As we watch Fernand's path, consider how solar activity might subtly amplify these systems. Studies suggest that increased cosmic rays during solar minima can seed more clouds, but in this peaking cycle, reduced cosmic rays, currently at negative 6.2% of the space-age average, might lead to clearer skies and hotter conditions, priming the pump for stronger hurricanes. The intensity is ramping up, and you won't want to miss how this ties into even more explosive events lighting up our skies. Now, as Aaron dissipates, attention turns to tropical storm Fernand, the sixth named storm of the 2025 Atlantic hurricane season, currently at 28.8 degrees north, 61.2 degrees west with 40 miles per hour winds, moving north-northeast at 16 miles per hour. Forecasts from the National Hurricane Center indicate it could strengthen slightly, but remains a threat for rough seas and rip currents along Bermuda and the U.S. East Coast. What's fascinating is how these cyclones echo larger cosmic patterns, their spiral arms resembling the arms of our Milky Way galaxy, a visual metaphor for the interconnectedness of scales in the universe. NOAA's prediction for an above-normal season, with 13 to 19 named storms and 6 to 10 hurricanes, is playing out, driven by La Niña conditions and record-warm Atlantic waters. These storms aren't just weather events. They redistribute heat and moisture globally, influencing everything from agriculture to ecosystems. As we watch Fernand's path, consider how solar activity might subtly amplify these systems. Studies suggest that increased cosmic rays during solar minima can seed more clouds, but in this peaking cycle, reduced cosmic rays, currently at negative 6.2% of the space-age average, might lead to clearer skies and hotter conditions, priming the pump for stronger hurricanes. The intensity is ramping up, and you won't want to miss how this ties into even more explosive events lighting up our skies. Speaking of explosions, let's turn to the night of August 19th, when a breathtaking fireball streaked over southern Japan, transforming midnight into daylight with a brilliant white flash tinged with blues and greens. Captured on videos from Kagoshima City and near the iconic Sakurajima volcano, this meteor, likely a fragment from a comet or asteroid, burned up in the atmosphere, creating a spectacle visible for hundreds of miles. Witnesses described it as bright as the moon, with fragments scattering near the horizon. The Japan Meteorological Agency and local observatories confirmed the event around 11 p.m. local time, noting its path over the active Sakurajima, which has been erupting frequently this month. Just days before, on August 17th, Sakurajima sent ash plumes 5 kilometers high, and ongoing activity includes volcanic explosions from Minamideki crater, with volcanic ash advisories issued as recently as August 24th? Is this fireball an omen for heightened volcanic unrest? While science attributes meteors to orbital debris, the timing sparks curiosity. Sakurajima, part of the Era caldera, has been in a state of continuous eruption since 1955, with over 100 events this year alone. Volcanic activity worldwide is on the rise. The Global Volcanism Program reports increased eruptions at sites like Kilauea in Hawaii and Popocatépetl in Mexico. But back to the fireball. Such bolides release energy equivalent to tons of TNT, sometimes generating shockwaves or even meteorites. This one, glowing in vivid hues from ionized metals like magnesium and sodium, reminds us of the Perseid meteor shower's peak earlier in August, though this was a sporadic event. In the context of solar cycle 25's peak, more cosmic rays are being deflected by the sun's magnetic field, but fireballs persist as harbingers of space's unpredictability. Could it signal broader cosmic shifts? That's for you to ponder as we connect the dots to larger solar system dynamics. Keep reading, because the real intrigue lies in how this aligns with a wandering celestial visitor that's stirring up the heavens. Returning to the solar eruption, NASA's space weather models paint a vivid picture of its sweep across the solar system. In the ecliptic plane view, the sun sits at the center, with Earth as a yellow dot and Mars as red. The CME from the August 19th to 20th filament eruption propagates outward, grazing Mars and extending toward the E90 zone, where our intriguing comet resides. This isn't just any outburst, it's one of the most visually striking in solar cycle 25, which began in December 2019 and is now at its maximum, with smoothed sunspot numbers around 115. The cycle's progression, tracked by NOAA, shows a faster rise than predicted, leading to more frequent flares and CMEs. As the plasma cloud expands, it could interact with planetary magnetic fields, potentially triggering auroras on Mars, observed by MAVEN, or even influencing comet tails. Enter Comet C/2025 K1 Atlas, discovered earlier this year by the Asteroid Terrestrial Impact Last Alert System. As of August 24th, it's cruising inward on a hyperbolic orbit from the Oort cloud, having passed its closest Earth approach on August 13th at 0.58 astronomical units. Its perihelion is set for October 8th, 2025, at a scant 0.33 astronomical units from the Sun, where intense heating could make it brighten to magnitude 13.5 or better, visible in small telescopes. But here's the twist. The CME's path aligns geometrically with the comet's position, potentially disrupting its dusty plasma envelope. Comets like this are icy relics from the solar system's formation 4.6 billion years ago, releasing gases that form glowing coma and tails under solar radiation. If the CME sweeps by, it could enhance the comet's ion tail or even cause outbursts, as seen with Comet Encke during past solar storms. Speculatively, this interaction hints at broader plasma dynamics. The comet's approach might be correlating with heightened solar activity, though causation remains unproven. As it nears the Sun, expect unconventional events, not just standard flares, but sudden filament lifts or interactions with persistent coronal holes. That long-lived coronal hole, rotating past Earth 12 times this cycle, will deliver its high-speed stream around September 22nd, coinciding with the autumnal equinox, and again near the comet's perihelion in October. This structure has been linked to past geophysical events, like the M7.7 Myanmar earthquake on March 29, 2025, and the staggering M8.8 Kamchatka megaquake on July 29, 2025, the largest since 2011's Tohoku event. That quake, off Russia's Kamchatka Peninsula, triggered tsunami warnings across the Pacific, with waves up to 1 meter in some areas. USGS aftershock forecasts predict ongoing activity, with a 5 to 10% chance of M7 plus events in the coming weeks. Could these alignments foretell significant Earth shifts this fall? The data suggests patterns. Solar wind compressions can subtly stress tectonic plates via electromagnetic coupling, though mainstream science views this as correlative, not causal. As we track the comet's path, disturbances in its direction are already noted, setting the stage for a cosmic convergence that demands your attention through to the climax. Advancing our timeline to late September and October, the comet's trajectory reveals even more compelling alignments. On August 24th, Comet C 2025 K1 Atlas is inbound at a steep inclination, about 175 degrees retrograde, deviating just 5 degrees from the ecliptic. The filament eruption originated from the Sun's eastern limb, expanding outward to encompass the comet's vicinity in 7 to 10 days. By early October, it nears Mars closely, with an alignment involving Mercury, the Sun, and Mars around October 1st. This heliocentric conjunction could amplify solar outputs, as planetary positions sometimes correlate with flare activity via gravitational tides or magnetic resonances. Though debated, historical data from cycles 23 to 24 show peaks during such geometries. Then, on October 21st to 22nd, we reach superior conjunction. The comet aligns with the Sun as viewed from Earth, hidden in its glare, but potentially peaking in brightness post-perihelion. At this moment, planetary geometry intensifies. Mercury, Mars, Venus form a near square with the Sun, while Earth stands opposite, reflecting full illumination toward the comet, like a full Earth phase. From the comet's perspective, our planet shines brilliantly, its city lights and atmospheric glow adding to the spectacle. Observations suggest the comet emits unusual light signals, possibly from complex dusty plasma interactions, where charged particles create aurora-like glows. But consider Earth's emissions. Our radio waves, artificial lights, and even biological luminescence make us a beacon in the void. This mutual gaze evokes a sense of cosmic dialogue, where solar and interstellar energies converge to foster new awareness. Before this peak, September brings its own energetic crescendo. Eclipse season kicks off with the new moon on September 2nd, conjunct the fixed star Regulus in Leo, symbolizing leadership and heart-centered energy in astrological lore. Then, the total lunar eclipse on September 7th to 8th casts the full corn moon in blood-red hues, visible across Europe, Africa, Asia, Australia, and New Zealand, a penumbral to total event lasting over an hour, caused by Earth's shadow-blocking sunlight. Lunar eclipses often coincide with emotional releases, but scientifically, they reveal atmospheric dust levels via the moon's color. Following is the partial solar eclipse on September 21st, overlapping the autumnal equinox on September 22nd at 2:19 p.m. Eastern Daylight Time. This equinox, when day and night equalize, marks the sun's crossing of the celestial equator, supercharging the eclipse's visibility over Antarctica and parts of the South Atlantic, though more penguins than people will witness it. In between, heliocentric alignments abound. Neptune, Saturn, Earth, and Sun align around September 19th, potentially influencing outer planet magnetospheres. Venus and Jupiter draw close heliocentrically, while Mercury and Mars align near the comet's October ingress. Saturn reaches opposition on September 21st, shining at magnitude -0.6 in Aquarius, ideal for viewing its rings. Neptune follows on September 23rd at magnitude 7.8, portal of transformation. Solar wind from the coronal hole hits during the equinox, possibly enhancing geomagnetic activity to KP5+ levels, sparking global auroras. Historically, equinox periods see heightened space weather due to the Russell-McFerrin effect, where the sun's magnetic field aligns favorably with Earth's. As we bridge to October, the comet's close Mars approach, superior conjunction, and perihelion promise significant activity, perhaps flares, CMEs, or even comet outbursts visible from Earth post-sunset. But let's expand on these eclipses' profound implications. A total lunar eclipse like September's occurs when the moon passes through Earth's umbra, turning rusty red from Rayleigh scattering, sunlight filtered through our atmosphere, bending reds inward. This blood moon has inspired myths worldwide, from Incan jaguars devouring the moon to Hindu demons, Rahu and Ketu. Scientifically, it measures volcanic aerosols. After Sakurajima's recent blasts, expect a darker hue. The partial solar eclipse on September 21st obscures up to 20% of the sun over remote regions, a ring of fire for annular types. But here, partial, safe viewing, requires solar filters to prevent retinal damage. Eclipses align sun, moon, earth, amplifying gravitational pulls that can subtly influence tides and even seismic activity, with studies showing slight upticks in earthquakes around syzygies. The equinox adds balance. Earth's axis tilts neither toward nor away from the sun, equalizing hemispheres. In 2025, this falls amid a busy sky. Meteor showers like the September Epsilon, Perseids peak early month, while the Draconids in October could yield 10 to 20 meteors hourly. Cometary dust from these aligns with our fireball discussion, as meteors stem from similar sources. Now, weaving in volcanic ties, Sakurajima's activity, with ash extending southeast at flight level 080, correlates with regional tectonics. The M8.8 Kamchatka quake on July 29, at a depth of 10 kilometers on the subduction zone, released energy equivalent to 32,000 Hiroshima bombs, triggering over 500 aftershocks. This megathrust event on the Kuril-Kamchatka Trench echoes 1952's M9.0 quake, highlighting Pacific Ring of Fire volatility. Myanmar's M7.7 in March struck the Sagaing Fault, causing landslides and infrastructure damage. Recent quakes include M6.3 in the Solomon Islands on August 16th, tied to subduction. Could solar-comet interactions exacerbate this? Plasma disruptions from CMEs might induce currents in Earth's crust, stressing faults. A hypothesis supported by correlations in studies from the Journal of Geophysical Research. As the comet nears, watch for synchronicities. Its plasma tail, ionized by solar wind, could resonate with Earth's ionosphere, potentially boosting Schumann resonances, Earth's electromagnetic heartbeat at 7.83 Hz, linked to brainwave states and consciousness. Delving into consciousness, these events invite reflection on humanity's place in the cosmos. The comet, a messenger from the Oort cloud, a spherical shell of icy bodies extending a light-year out, carries pristine materials from the solar nebula. As it heats, outgassing reveals spectra of water, carbon dioxide, ammonia, building blocks of life, supporting panspermia theories where comets seed planets. Its unusual light signals might be fluorescence from organic compounds, or plasma excitations mimicking bioluminescence. Earth's full moon view from the comet underscores our visibility. With albedo 0.3, we reflect 30% of sunlight, plus anthropogenic lights making us a nighttime glow. Satellite constellations like Starlink, noted interfering with comet observations, highlight human impact. Over 5,000 satellites now orbit, brightening skies and complicating astronomy. Yet, this era of discovery, with missions like NASA's Parker Solar Probe sampling CMEs or ESA's Comet Interceptor targeting future visitors, fuels wonder. Solar Cycle 25's intensity, with X9 flares in October to 2024 and recent M7.7 triples in May 2025, recalls Carrington event of 1859, which sparked telegraphs aflame. Today, a similar storm could cost trillions in blackouts. Hurricanes like Erin exemplify climate ties. Warmer oceans from greenhouse gases boost intensity, with 2025 season amplified by La Niña's cooler Pacific waters shifting jet streams. Fireballs, occurring over 100 times yearly above magnitude -4, remind us of near-Earth objects. NASA's NEO program tracks 30,000 plus, with potential impacts like Chelyabinsk 2013. Volcanoes add Sakurajima's 2025 eruptions, ejecting andesitic lava, contribute to global cooling via sulfur aerosols, countering warming. Quakes reshape landscapes. The Kamchatka event uplifted coastlines by meters. As September's alignments unfold, with planets spanning the sky, Venus brilliant at -4.5, Jupiter at -2.8, night skies beckon observation. Use apps for tracking. Binoculars reveal comet details post-perihelion. Building suspense, October's convergences could culminate in spectacular displays. Around October 1st, the Mercury-Mars-Sun alignment with the comet near Mars might trigger solar flares as tidal forces peak. Mars, at 1.5 astronomical units, experiences dust storms amplified by solar wind. A CME hit could globalize them. The Superior Conjunction on October 21st to 22nd hides the comet but positions it for post-sunset visibility in November, potentially tail extended. Perihelion on October 8th sees it skim 0.33 astronomical units, risking disintegration like C 2024S1 did last year, but if intact, brightness surges. Venus-Jupiter's close approach adds evening splendor. Geomagnetic forecasts. If the coronal hole persists, its stream hits near perihelion, possibly G3 storms with auroras to 50-degree latitude. Earth shifts? Tectonic stress from lunar tides and solar induction could spike quakes. Monitor USGS for real-time. Broader implications? These events foster global unity, as shared skies transcend borders. Educational value? Teach plasma physics. Sun's corona at 1 million degrees Celsius defies intuition, explained by magnetic reconnection. Hurricane dynamics. Coriolis force spirals them, akin to galactic arms via angular momentum. Meteors? Atmospheric entry at 72 kilometers per second ionizes air, creating trails. Comets. Halley's 1986 visit inspired Giotto mission, revealing dirty snowballs. As things heat up, with fireballs, massive hurricanes, solar outbursts geometrically linked to the comet, the universe seems to whisper secrets. We've covered solar eruptions' sweep, hurricanes' might, fireballs' omens, comets' journey, eclipses' portals, alignments' energies, and potential shifts. This interconnected web encourages vigilance. Observe, question, connect. The cosmos is alive, evolving, and you're part of it. Don't turn away now, as the best may yet come. To truly appreciate this, let's explore historical parallels. Solar cycle 24 peaked in 2014 with fewer spots, but 25's vigor rivals cycle 23's 2000 maximum, which saw X-class flares disrupting GPS during a rock warp prep. Filament eruptions like August's Echo 2022's Canyon of Fire, carving a 200,000-kilometer gash. Hurricanes, 2005's Katrina, Category 5, devastated New Orleans. Aaron's rapid growth mirrors, underscoring preparedness. Noah's goes. Satellites provide real-time data for evacuations. Fireballs, 1908. Tunguska event flattened 2,000 square kilometers. Modern detection via infrasound networks prevents surprises. Comets, Hale-Bopp, 1997 shown at -1 magnitude, inspiring awe and myths. C 2025, K1 could similarly captivate. Eclipses, 2017's American total solar drew millions, boosting economies. September's pair offers remote viewing via live streams. Volcanism, 1815. Tambora caused year without summer. Sakurajima's activity, monitored by JMA, ensures safety with evacuation zones. Quakes, 1960. Valdivia M 9.5 remains largest. Kamchatka's 8.8 underscores plate tectonics. Eurasian Pacific subduction drives 80% of global seismicity. Consciousness ties. Schumann resonances fluctuate with solar activity, potentially affecting mood. Studies link low frequencies to creativity. Interstellar energies. Galactic cosmic rays, modulated by solar wind, influence cloud formation per Svensmark theory, tying space to climate. As we approach fall, these phenomena crescendo, urging engagement. Join citizen science like Globe at Night for light pollution maps, or Zooniverse for comet classification. To truly appreciate this, let's explore historical parallels. Solar cycle 24 peaked in 2014 with fewer spots, but 25's vigor rivals cycle 23's 2000 maximum, which saw X-class flares disrupting GPS during a rock warp prep. Filament eruptions like August's Echo 2022's Canyon of Fire, carving a 200,000-kilometer gash. Hurricanes, 2005's Katrina, Category 5, devastated New Orleans. Aaron's rapid growth mirrors, underscoring preparedness. Noah's goes. Satellites provide real-time data for evacuations. Fireballs, 1908. Tunguska event flattened 2,000 square kilometers. Modern detection via infrasound networks prevents surprises. Comets. Hale-Bopp, 1997, shown at -1 magnitude, inspiring awe and myths. C. 2025, K1 could similarly captivate. Eclipses. 2017's American total solar drew millions, boosting economies. September's pair offers remote viewing via live streams. Volcanism. 1815. Tambora caused year without summer. Sakurajima's activity, monitored by JMA, ensures safety with evacuation zones. Quakes. 1960. Valdivia M 9.5 remains largest. Kamchatka's 8.8 underscores plate tectonics. Eurasian Pacific subduction drives 80% of global seismicity. Consciousness ties. Schumann resonances fluctuate with solar activity, potentially affecting mood. Studies link low frequencies to creativity. Interstellar energies. Galactic cosmic rays, modulated by solar wind, influence cloud formation per Svensmark theory, tying space to climate. As we approach fall, these phenomena crescendo, urging engagement. Join citizen science like Globe at Night for light pollution maps, or Zooniverse for comet classification. As we delve further into the comet's journey, recent observations of Comet C 2025 K1ATLAS show it brightening rapidly, currently at magnitude 11.7 as of August 14th, with expectations to reach 7.5 by perihelion on October 8th. This inbound traveler from the distant Oort cloud is moving about 3 degrees per day across our skies, offering amateur astronomers a prime opportunity to track its progress with telescopes or binoculars as it approaches the sun. Imagine the thrill of witnessing its coma expand and tail elongate under solar heating, potentially creating a stunning display in the evening sky post-perihelion. A reminder that these ancient icy bodies hold clues to the solar system's origins, and their visits can ignite a sense of wonder that keeps us gazing upward, eager for the next revelation in this cosmic ballet. Turning to recent seismic developments, just days ago on August 21st, a magnitude 7.5 earthquake struck the South Atlantic Ocean in the Drake Passage, marking another significant event in this active year. This quake, along with the M6.3 in the Solomon Islands on August 16th, adds to the pattern of heightened tectonic activity we've been tracking, possibly influenced by the broader energetic shifts from solar and cosmic influences.